Fourth day, chapter 5. We're integrating functions some more, and we're going to do some more u substitutions, but these u substitutions are going to be a little bit more advanced and give you a little bit more trouble. So I'm going to start by zooming this, create a little bit more space. So at first glance, when we look at problem number 1, we're probably going to go, okay, I see a quantity on the bottom, and if I see a quantity on the bottom, the pattern that we've kind of recognized is that that bottom should probably be u. So let's try that and see where it takes us. U equals x plus 1. So then my du and my dx are the same thing. So rewriting my integral, what it looks like I have is I've got the integral of a fraction, and I've got a u on the bottom, and that u, it appears, is going to be squared. And then my dx is the same thing as my du. But my issue is I've got a 2x that remains on the top. So I'm looking at this 2, and I'm seeing a constant. So I'm going to pull that constant out. But then I've got this x left over. So what am I going to do with this x that I have left over in the numerator? Well, that x would be the same as this x. So what is that x equivalent to? Well, according to our u equals x plus 1, that x would be the same thing as u minus 1. So let's take this x out, and let's put a u minus 1 in its place. And now I have an integral that has been rewritten, and it's equivalent. It's all in terms of u now. So now if we wanted to do this integral, let's see. So I've got multiple terms in the numerator, so I think I'm going to make multiple fractions out of this. So I've got 2. I've got the integral of u over u squared minus 1 over u squared du. And so let's see. So that first term, that's u over u squared. That would be the same as 1 over u. Minus 1 over u squared. Well, I'm going to write 1 over u squared as u to the negative second du, and I'm hoping you've already made the connection that with these two different terms, we're going to do two different rules. First one, if I did make it u to the negative first, that power rule won't work. So how about 2 natural log of absolute value of u minus, add 1 to the power, u to the negative first, divide by the new power. I'd be dividing by a negative 1 plus my c. So clean it up. 2 natural log, let's make this blue, 2 natural log absolute value of my u that I'm going to put back in plus 1 over my u plus my c. What's my u? My u is that x plus 1 that I had. And here's an x plus 1 also. There's my solution. So there, one part done. So number 1 took care of that. So I took that u substitution. That was pretty complex, and I had to make some changes once I was done with that u substitution. Second one's going to be a little bit more difficult. Second one, I see multiple terms in the numerator, so you might think about I could take this thing and I could split it. I'm just going to tell you this is more a logic type problem, so I'm going to kind of get you started here. We're going to say u is the same thing as the square root of x minus 1. We're going to make u the denominator. And what I want you to do is I want you to just kind of trust me on this for a second and kind of see where this takes us. So if that's the case, our du, 1/2 x to the negative 1/2 power being multiplied by dx. So the dx that's in the problem, multiplied by 2, multiplied by square root of x, dx. I'm sorry, that would be square root of x, 2 root x being multiplied by du would be what that would be equal to. So in my problem, let's start rewriting this integral. If I rewrite this integral symbol, fraction's not going away. I'm going to throw in place of dx, 2 square root of x and du. And my denominator is a u, but the tricky thing is I still have this root of x plus 4 up there in the numerator that I haven't accounted for yet. So technically what I have written up there isn't all in terms of u. I need to take care of a couple things. What do I need to take care of? I have a problem with anything that's an x because I shouldn't have that x in there. So what I'm going to highlight now is I've got this root x that doesn't belong. And I've got this other root x over here that's a bit of a problem. So is it possible that we could isolate, or we could write root of x in terms of a du? Yes, it is, because here's a root of x. So now that root of x would be the same thing as u plus 1. So I replace all the root of x's with a u plus 1. My new integral, well, let's see. I've got a u plus 1 plus a 4 in the numerator of my fraction. I've got u in the denominator of my fraction. I've got that 2. That's a constant that I'm going to pull to the outside, and I've got another root of x that I'm going to replace with a u plus 1 to go along with my du. So I've changed this thing up. I've got a new integral. Well, now let's rewrite this. Let's clean all this up. So I have 2 times the integral of u plus 5 in the numerator of that fraction. And I also have a u plus 1 that is being divided by a u. I better make sure that I get a quantity around my u plus 5 with a du. So now what I see in this numerator is I see that I've got a binomial, or a pair of binomials being multiplied together. So 2 integral u squared plus 5u plus 5 all over u. Actually, how about if we make this a 6u plus 5 with a du. So splitting it into 3 separate integrals, 2 integral u plus 6 plus 5 over u du. Are those integrals we can do? They absolutely are. So let's see, integrating this thing. How about I've got a 2 for a constant. I've got a 2 for a constant, and I'm going to be multiplying this thing by a 1/2 u squared plus 6u plus 5 natural log absolute value of u plus my c. Plug your u's back in. I'm going to distribute the 2. So I've got u squared plus 12u plus 5 natural log absolute value of u plus my c. Whoops, I better change that 5 and make it a 10. And now plugging my u back in, we're going to finish this thing off. So everywhere I see a u, I'm going to have a, what was it? Square root of x minus 1. So here's a square root of x minus 1. That's being squared. Plus a 12 being multiplied by the quantity, square root of x minus 1, plus a 10, natural log, absolute value, square root of x minus 1, plus my c.